How does a missile accurately reach its target? Do all objects that fly move in the same way? In movies, shells, rockets, and missiles may look similar, but they work differently. A shell fired from a cannon or mortar follows a curved path under the effects of gravity and air resistance once its initial speed and direction are set. After launch, it cannot change direction or adjust its target on its own. A rocket keeps flying by burning fuel to produce thrust. When it also has a guidance system that directs it to a target, it becomes a missile. In other words, a missile not only flies by itself, but also continuously calculates its position and adjusts its course during flight. Newton's laws of motion explain how this works. A shell follows a fixed trajectory because the law of inertia keeps it moving in the same state unless an external force acts on it. A missile, however, keeps burning fuel to generate thrust. It moves forward by expelling hot, high-pressure gas backward. Instead of simply flying, it generates its own force, continues to accelerate, and changes direction as it flies. So how can a missile accurately reach a distant target? The key is mathematics. A missile uses GPS, or an inertial navigation system, to calculate its current position and speed. It uses radar and other sensors to detect the target's position and direction of movement. A computer then represents both positions as coordinates and calculates the most efficient flight path. If the target moves, the computer recalculates the coordinates, and the missile adjusts its course accordingly. This process does not happen just once. The missile repeats these calculations hundreds of times every second during flight. This process uses functions, coordinates, vectors, derivatives, probability, and statistics. Functions describe how position and speed change over time. Vectors calculate direction and magnitude. Derivatives help find the fastest and most stable path. Sensors always produce some error, so the system compares multiple data sources and selects the most reliable values using probability and statistics. In other words, invisible mathematics becomes the missile's eyes and brain. Missiles fall into two main types based on how they fly: cruise missiles and ballistic missiles. Cruise missiles fly like airplanes, using an engine to stay at low altitude. They can also change their route during flight. Ballistic missiles, in contrast, use powerful thrust to reach high altitude and then travel along a curved ballistic path for most of their flight. Today, some ballistic missiles can make limited course corrections with guidance systems. However, they generally have much less flexibility than cruise missiles. Recently, drones have begun replacing missiles in some missions. Drones are less expensive, can stay in the air for a long time, and can perform both surveillance and attack missions. However, drones also rely on mathematics to calculate their position and reach a destination. They use coordinate calculations, path planning, and sensor data analysis. In school, many students wonder, where will they ever use functions, coordinates, and vectors? In fact, modern aircraft, drones, self-driving cars, satellites, and even missiles all use these mathematical ideas to determine their position and find the most efficient route. Mathematics is not just about calculating numbers. It is the language that helps us understand a moving world and find the most accurate path.